Hello everyone. So in this video, we are going to look at how to actually do two-sample inference in Minitab, or StatCrunch will work similarly. So in the past couple videos, I haven't provided any examples of how that would go, partly because it's kind of hard to do so, because usually you're not going to get the summaries of data. You're going to get the actual data. And so I can't really do that well on slides, so I thought I'd just take you sort of right to the source and go through on Minitab and work out a few examples. Okay, so we have three different types of inference that we talked about in the last two videos, and that was unpooled two-sample inference, pooled two-sample inference, and then the third one I'll call paired inference, paired two-sample inference. So we had pooled, unpooled, and paired. So we're going to start with this data set. We'll use it for all three types, and so I'll show you on Minitab how to go through and do all three types of inference. Okay, so we're going to start with the data. So I have 10 points of data in each group. I have two groups, group 1 and group 2, and this data is a classic data set called the sleep data set. And so so we have two groups of 10 people. Now in reality, for this data, there are just 10 people, okay, and they gave them two different drugs and then looked at how much more sleep than average they got. So these numbers are how much more sleep on average they got taking each drug. So if we were to do this in real life, we'd have to use a paired t-test to do some inference to see which drug was better. But because we're just doing this for demonstration purposes, we're going to go through all three. Okay, and of course this would be paired because each person is the same. So if you look here for the first row of group 1 and group 2, those measurements are on the same person who took different drugs. Okay, so first one, unpooled t-test. So to do any sort of inference, we're going to go to Stat. Okay, for me in Minitab on a Mac, you're going to go to Stat and then Basic Statistics. And then I have a number of options. And before, we worked with one sample t and one proportion. Now I'm going to do two sample t. Okay, and so for me, it opens up this menu. It will probably open up a different menu, or it definitely will, for a Mac, for a PC or a Linux machine or anything else that you have. But if you have a Mac, this is going to be great. All right, so in this interface here, you don't have sort of many options going on, but at the top, you have different ways of inputting the data. So you have an option where both samples are in one column. And so that would be the case where if I had one column that said the measurements and then a second column that said which group that they were in. Okay, so I could arrange the data that way. And if I did, it's going to ask me where the samples are and then where the IDs are. Okay, so there would be one column that had all the data, and then in the second column, it would say like observation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But that's not how we have the data. We have it in each data, each group is in its own column, and so I'd pick each sample is in its own column. Now there is a third option, which is the summarized data. So if I gave you the means and the standard deviations, then you could also do this. So if I click on that, it gives you options. And so I was playing around with random stuff, and so there were numbers in here. But when I take them away, Okay, you can give it the sample size, the sample mean, and the standard deviation for each sample, and then it'll go on with its business. But of course, we are in this option. Each sample is in its own column. Okay, and so I'll say that group 1 is sample 1 and group 2 is sample 2. So how I do that and how you're going to do that similarly on whatever type of machine that you're on. When I go to click, I click this box, it brings up the 2 different columns that you have. And so I'm going to click on group 1 and select, and then for group 2, select for sample 2. Then I have a number of options that I need to look at. So for the options, it's going to ask for the confidence level. So for instance, if I was doing a a confidence interval for this case, 95% is the default, but of course, you could do any confidence level in here. The next one is also important, the hypothesized difference. So if I was doing a hypothesis test and I thought the difference was not 0, so for us it's always going to be 0, but if it isn't for some case, you put in the difference here. And then also important is the hypothesized difference. Okay, and those are your 3 options: less than, greater than, or not equal to. And then the last little bit, which is one small box that you can click, but it is very important, is the assume equal variances option. So of course we talked about unpooled and then pooled, okay, the 2 different tests. How you change from unpooled to pooled is that you'd click this box. Okay, so we aren't going to assume equal variance in this case, so we don't click the box. Okay, and so when I click OK, and then I'm fine. Now it gives you a few graphic options, the individual value plot or the box plot. I don't want either of those. So I'm going to click OK, and it's going to give me over here, okay, the method, the descriptive statistics, which are great. Then it's going to give me the confidence interval here, and the p-value, okay, and the test. Okay, so it'll give you the hypotheses, the t-value, okay, the degrees of freedom, which that formula turned out to be 17. Okay, the big formula that is hard to use. If you calculated that, it would be 17. This is your critical value, and then here's your p-value. So it gives you everything that you need to make or do inference. And so if you looked here, if you wanted to sort of make some sort of inference based on the confidence interval, you would see that 0 is contained in that interval. And so if we were to do a two-sided hypothesis test, which we did down here, we would probably fail to reject. Okay, and in fact, if you look down here, you get a p-value of 0.08. Okay, and at a 0.05 level, you would fail to reject the null hypothesis. And lo and behold, this confidence interval says the same thing, that 0 is contained in that interval. Okay, and so therefore, it's probably not a great idea to assume otherwise. All right, so that is the 2-sample unpooled test. And so as you might imagine, if I delete that and I want to do the pooled inference, I'm going to do the same thing, basic statistics, 2-sample t, each sample in its own column. Sample 1 is group 1, sample 2 is group 2. Then in my options, nothing's going to change because I haven't really talked about an alternative hypothesis. Maybe just for fun, I'll change this. No, I'll keep it the same to see how equal variances will change or not change my result. So if I click Assume Equal Variances, that's the only thing that I change. I'll click OK. All right. Descriptive statistics are probably going to be the same, but the standard error is going to be different. Okay, here's the confidence interval, and here's the hypothesis test. So it turns out that the unpooled and pooled difference unpooled and pooled outcomes are pretty much the same. Okay, they change just slightly, but not the same. And so you'll see down here that the degrees of freedom for the pooled is 1 more than the degrees of freedom for the unpooled. The t-value is like 1/100ths off. Okay, and the confidence interval is just different, but there's really no change there. Lastly, let's talk about the paired t-test. Okay, so that's where a bigger difference is going to come. If I go back to stat, basic statistics, and then I go down here, I have 1 sample Z, 1 sample T, 2 sample T, and then I have a paired T option. That's the option that you want to pick if you're doing a paired t-test or a t-test with dependent samples. Okay, and that's the test really that we should be doing for this data, because there were really only 10 people involved, and so that's what we should be using. So sample 1, we're going to go with group 1 again, and sample 2, group 2. Options, it gives us the same options, except we can't pool or unpool the variances, of course, because we're doing paired T. Okay, so confidence interval, hypothesized difference, and then the alternative hypothesis. Okay, graphs, you have a few, but none that we're going to worry about here. And if I click OK, I'm going to get new output. Okay, really it's the same data, but the standard errors are going to be different. And so when you go down here, you're going to get a 95% confidence interval for the difference. And lo and behold, if you look at this, it does not contain 0. Okay, it doesn't contain 0, and so there might actually be a difference there. Okay, and then if you go down here, you'll see through the test that it has, now it's not mu1 is equal to mu2. It's now that the difference is equal to 0 versus the difference is not equal to 0. You'll come down here, you'll get a t-value and then a p-value, just like we had before. Now, the one thing that this doesn't give you is the degrees of freedom for the test. So the degrees of freedom for a paired t-test is going to be the number of pairs minus 1. Number of pairs minus 1. So before we had different n1s and n2s for each group. Now we only have one single n. Because, of course, the observations are paired, we need to have the same number in each group. So we don't take, so for instance, it might be tempting to add up all of this and then minus 2, like you did in the pooled sense, or even minus 1, but the degrees of freedom is not 19 or 18 or 17, it's actually 9, because it's the number of pairs minus 1. Okay, so confidence interval there, and then of course hypothesis test. Again, the p-value, which is 0.003, if we compared it to 0.05, we would reject, and we would say that the difference is not equal to each other. Okay, and the confidence interval up here agrees with that down here, agrees with the statement down here. You'll find that they always are going to agree, okay, if the alternative hypothesis and the number of and the confidence interval are both two-sided. Okay, so those are the 3 options that you have and how Minitab does them.